Hi there, this is a presentation about core data in iOS, including a short demo with XCode. Core data is an object-oriented framework to store and access data in iOS and OS X. So it's a way of managing your model in a project where you will have typically a model, a view, and a controller. It's an object graph, so it's fully object-oriented, backed by a database, which is not necessarily object-oriented. It could be an SQL database or other kind of database. How do we use it? We create a visual mapping between the database and the object, which are called entities, as we will see later. And then we manage this object through object-oriented APIs and access fields using Objective-C properties. Objects are accessed through a context of belonging to the class NSManageObjectContext, as in any entity framework. You can create a context in several ways. The most important ones are the managed document class, which is the more modern version, used also by iCloud. The traditional way is through the persistent store coordinator, and we are going to use that today in the demonstration. An object is fetched through a request of type NSFetchRequest through the command execute fetch request, which is a message passed to the context in Objective-C fashion. You insert an object by using the insert new object for entity for name. So an object belongs necessarily to an entity. Searching for results involves several steps. First, we define what kind of result we would like to get. In this case, we are looking for persons. Then we narrow down a search. In this case, we want to look for persons of gender female between the age of 18 and 30. And finally, if we get any, we can sort the results based on the name of the person. For more information, have a look at these references. There is a course on iOS by Stanford University on iTunes University. The lessons 13 and 14 cover core data specifically. A book by Marco Zarra on core data has been recently updated to the second edition, and it has a lot of information on core data, including how to improve performance. On the Ray Vanderlich website, there is a tutorial on core data, also recently updated. And on YouTube, you find a lot of code examples by Dennis Robertson. What we are going to do today is to use a template in XCode to create a master detail project. This is how the project looks like in its original form. It's very simple. So we have a master view where you can enter an event with a timestamp, and if you click on the event on the table, you will be presented with a detailed view where the same information is formatted slightly differently. You can then go back to the master view and add a new event and so on. Delete and add new events as you please. We are going to use that to create something a little bit more challenging, namely a simple library catalog. Here we will have a master view where we can input authors. Then when we click on an author in the list, we will be given the opportunity of entering as many books as we like written by that author with the publication year. Then we can go back to the AutoView and select another order. As before, we can delete and add entries as we like. So we now go to XCode. We select the master detail application as a template. We enter a name for our project, and we make sure that the core data option is selected. Before we change the master detail project to fulfill our needs, let's analyze the code as it is. We have here a data model with a single entity, an event entity, which has a single attribute, a timestamp. The storyboard has two views, the master view, which is a table view, and a detail view. If we run the app, we see that a button is available to add a new event object. If we select that, we activate the detail view, and we can go back to the master view, delete an entry if we like, create it again, and so on. So let's see how this is done. The app delegate takes care of the core data infrastructure by creating a persistent store coordinator. It also passes the context to the master view controller through a property, manage object context. The master view controller conforms to the fetch result controller delegate protocol, and it has a fetch result controller property. This is the object that will fetch data from the core data storage and present it to the view for display and other operations. This is done in the accessor of the fetch results controller property, which creates a request based on the event entity, and we look for all objects of type event because we do not set a special predicate to filter the search. If objects are found, these are sorted using the timestamp in reverse chronological order. The table view uses the fetch result controller object to get all information needed to fill the table. When the view is loaded, a button is created in the code, an add button, which, if selected, will activate the insert new object method to create and insert an object into the storage. The object is simply created by using the current time for the timestamp. Once one or more event objects are seen in the table, the user can select one of them and activate the detail view. To pass information to the detail view, the prepare for segue method is used. This will take the object selected by the user and pass it to the destination view, which is the detail view, through the setter of the detail item property. This we can see here, the property detail item, which is used to pass the information to the detail view controller. The detail view controller does nothing else but setting a label to the value of the timestamp. So this is what this sample project does, and we are going to try to use it for a more challenging project. Now we set up core data for our project. We use the existing data model that's already there for us, and we define two entities, author and book. We define the relationship between the two entities, create subclasses of an NSManage object for both of them, and finally use Objective-C categories to create and access the object in an encapsulated way. Using categories, we are able to maintain the management of the properties of the entities within the classes themselves. So we go to the data model. We take the event entity and we change its name to author. We remove the timestamp and we add a new attribute which is name, and it is of type string. Then we add a new entity, the book entity, with attributes title, also of type string, and year, which is the publishing year, of type integer. We now go to the visual editor, where we have a representation of these categories in a visual way, and we add a relationship between the two. To do that, we control drag from one entity to the other, and a relationship is created for us. Now, this relationship have two directions. From the author to the book, we define the relationship as books, and from the book to the author, we define it as who wrote. In this way, the relationships between author and book are defined in both ways. Now we select the books relationship, and we make sure that this is a too many relationship. This means that each author can have more than one book. This is also shown here graphically in our diagram. Next, we go to the subclassing of those entities. So we select both entities, we go to the editor, select that create NSManage object subclass for both entities, and add them to the project. Now we're going to get the book and author classes with their interface and implementation. Let's see if they're defined properly. The book class is okay because we have a properties of type author as we would expect. However, the author class still has a book which is of type NSManage objects, so the subclassing wasn't done properly. In order to fix that, we repeat the same operation again, create the subclasses, and now we see that the book is defined properly within the author class. In the implementation, we have dynamic properties, which means that these properties are going to define at runtime for us. Now we are going to use categories. We add a new file of type category, and we start with the author. Here we create a category called create. which is going to manage basically the creation and also the search for our author entity. In the interface, we define a method to create an author. This is a class method because we want to use it even if no instance of author is present. We give it as a parameter a name in order to define the author. And of course, we have to pass the context in order to do any operation with an entity. The method will return an author object, which is either a new object created for us based on the name, or an object which is already found in the storage. In the implementation, we define the author as an object which is still empty. We define also a request, which is based on the entity. And we need to define a predicate this time because we want to see if any author with the same name is already present. So the predicate will look for any author which has the same name as we pass in as a parameter. We also add a sort descriptor because although this is not needed in this specific case, as we expect to find at most one object in our search. Now we have to define a few more variables. And we proceed with our search. We expect to find some results. So we create an array which will contain the results found based on the context, the request, and also we have to use the error parameter. Now we have to analyze what kind of results we got. If nothing is returned at all, so not even an empty array, this is an error because our context doesn't work properly. However, if more than one author with the same name is returned, this is also an error because we want to define authors uniquely by their name. So we have to handle an error in both cases. If, however, we get an array which is defined properly as an array, but it is empty, so it has a count of 0, we are in the situation where we can insert a new object. So here we can create a new author. For that we use the insert new object for entity, which of course is the author entity. And also we have to use the context. So now an undefined author is created for us within the context. And we give it a definition by using the name passed as a parameter to the method. Now this is all done in memory so far, so in order to save it to storage, we have to use the context save message. The last case is if a single object is found. So in this case, we set our auto variable to this very same object that we found in our query, and we return the author as the return type of our method. Now let's look at the book create method. This is a little different because we need to pass a dictionary in order to accommodate all parameters needed. Also, the predicate is more complex because we search for each book that has a title and the name of the author equal to the one that we passed is a parameter. When we create a new book, we use the title and the year, which are passed as parameter. However, when we have to assign the author, we have to assign not just a string, but an object, because the book has a property of type author. In order to do that, we call the same create method that we discussed before for the author. This way, we get either a new author which was created for us based on the author name, or else an author that was found for us based on that search parameter. In this way, this method here can be used to create at the same time a book and its author if the author is not found in the storage already. Now we are basically done with the core data part. It is time for us to set up the GUI. We have to create two views, one to enter an author and one to enter a book. We also have to update the detail view to a table view for the books and create buttons and segues as needed. In the storyboard, we changed the name of the master view to an author view. Then we add a new view to accommodate a new author. We select a button and we add it to the author view. And this button is of type add, so with the plus sign. Then we have to create a new segue, so we control drag from the button to the view, and we will use a modal segue. Now we finish the definition of our view by adding a navigation bar with two buttons. Okay, we call it new author. Then we add a cancel button and a done button. Now it is important to set the style of this button to done because we're going to use that later. Then we can add a label and a text field. We call the label first name, Now we select both objects and we duplicate them. To create the last name section. In the AutoView, we change the cell to subtitle because we want to display both the name of the author and the number of books that he or she wrote. Now we remove the detail view and we replace it with a table view because we want to display more than one book. We create a new segue by control dragging. This is going to be a push segue. We add a title to the view. And likewise, we adjust the type of the cell. Now, because we are going to use the same code that was already prepared for us, we have to make sure that we use the same definition. So we use identifier show detail for this segue, as it is in the original code. Remember to check that all views have a controller assigned. We didn't create the author and view controller yet, so this is something that you have to do later. Also check that all segues are defined properly. And we are done with our GUI. Now comes the most challenging part, perhaps, where we have to adapt our controllers to the new design. We have to add new controllers for the author and book input views, as I mentioned. We are going to create a protocol to transfer author and book data between controllers. This is an important point. We have to update the master controller to view and create authors, and also the detail controller to view and create books. In the case of detail controller, we have to change its type to a table view controller and also make it conform to the NS fetch results controller delegate in order to display books in a view just like the master control does for the authors. We start by adding a new protocol within the controller group. We call this protocol add object delegate. And now we have to create a method for it. This method didUpdate is used to pass data as a dictionary between a controller and its delegate. The delegate is responsible for implementing the method itself in order to process the data as needed. When the data is ready, the originating controller will pass a message to its delegate in order to execute the method itself. We create now the AutoView controller. We add the protocol and we define a property which is the delegate which conforms to this protocol. Now we go back to the view and we assign each GUI element to its action or property. The passing on the information is done when the done button is pressed. Then we collect the first name and last name for the author. We format it in a single name to be passed. Then we call the delegate and we pass to it our dictionary. The book controller is similar. Here we pass a dictionary with a title and a publication year to its delegate. Now the master view controller is going to be the delegate for our author controller. So we add information about the protocol. We make the master view controller conform to the protocol by adding it to the list here. Then we add the author create interface in order to be able to create authors. And we implement the delegation method, which is the did update. When we receive the dictionary, we select the name from the dictionary and we pass it to the author creation method in order to create a new author. Now we have to set the delegate of the AutoView controller to the master view controller itself. To do that, we use the prepare for segue and we identify the AutoView controller as the one that has a set delegate selector. This identifies uniquely our target controller, and we can set the delegate to the master view controller itself, which is self in this case, with the set delegate setter. So in this way, the connection between the two is done and the message passing to the protocol will work. Next, we prepare the controller to use the author entity. So we set the entity in the fetch result controller accessor, and we also set a sort descriptor for it. We configure the cell to present the author name as well as the number of books which are in the catalog. Because of our new design, we can remove the add button code, and also we can remove the insert new object method. This is going to be handled differently. We can now build the app, and we see that we have the add button that will present us with a new author view. We can add the first name, the second name of the author, and this is going to be shown to us in the view. Now we have, of course, no books yet because we didn't have a mechanism to create books. This comes next with the detail view controller. We remove code which is not needed anymore. As we did before for the master view controller, we add our protocol information, which is going to be used to create new books. We define this controller as a table view controller, and we make it conform to the NSFetch results controller delegate to display object in a table, as well to our new protocol to add objects. In the implementation, we make the exact same connection between this controller and the book controller as we did before for the master and author controller. We add an author property as well as a manage object context and a fetch result controller property. When the view is loaded, we cast the detail item which was passed to us from the master controller to the author, and then we extract the name for the title of the view as well as the manage object context for further operation. We did some cutting and pasting, and we have now all the information that we need. We have namely a fetch result controller accessor, which we use to access the book entity. And now we look specifically for books that have an author which conforms to the name that was passed to us from the master controller. And we sort those books by year. Creation of a book is done similarly as before with message passing between controllers. Here we have to add the name of the author to the parameters that we pass to the method that creates the book, and we extract that from the author property. We display the book with its title as well as the year of publication in the cell of the table. Now we are ready to run the app. We are able now to select an author and to add a book for the author. So here for Mark Twain we add Adventures of Tom Sawyer, which was published in 1876. The entry for the author is updated accordingly. In summary, the standard XCode master detail project can be easily extended to build more complex apps. For entities, use the NSManage object subclassing to access properties in an object-oriented fashion, and use categories to encapsulate the management of the data for the entity within the same class that defines it. If you want to display core data results in a table, use the NSFetchResultController delegate protocol, which is built just for that and is well described in the master view controller in the standard project that we used. Finally, use protocols for loose coupling between controllers. This allows you to concentrate on the relationship between the controllers rather than on the data that you want to pass between them. Thank you for your attention.